Hey, hi guys. Can you hear me? Would you guys please turn on your cameras so I can see you guys? Okay, thank you. So, welcome to our third class. Today we'll be learning about number sequences. So before we start the class, we're going to do the preview as always, but just in case, I'm going to do a quick review on sequences. So just in case, do you guys know what the basic type of sequences that we're going to be talking about today? So there are mainly two types of number sequences, which are arithmetic and which is like 等差数列 or geometric. But today we're not going to talk about geometric. So for arithmetic, it's quite simple. Basically, you just start with the number a, and then you have an interval, which is usually d. Say d. Then the next number will just be a plus d. Then a plus d. Then a plus d plus d, and so on. And for geometric, it's basically the same thing. Instead of an interval, you have something like a ratio. So we can say that it's r. So the first number will also be a, and the next number will be a times the interval, which is r. And then the next number will be a times r all the way until the end. But today we're mainly going to be talking about arithmetic sequences, and we'll also be going through some of the general formulas and properties as we go on. But firstly, let's do the preview questions. I'll send out a poll for you guys to be first. Wait a second. Let me isolate it real quick. And get start. Okay. So most of you guys were able to get it right. The answer is 43. Does anyone want to come up and explain how they were able to solve the problem? If not, then I'll explain it. So this one is a pretty basic one. So it says that the 11th term in the arithmetic sequence is, so firstly we need to find the interval, which is the distance between each of the numbers. So that's going to be 7, wait, let me just take this out. So that is going to be 7 minus 3 equals 4. So this is our interval. And it asks for the 11th term in the arithmetic sequence. So for the 11th term, that means there are going to be 10 intervals in total. So 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This will be the final 11th term. That means that there are 10 intervals in between, and 4 times 10 is 40. So the answer will be 40 plus 3 equals 43. Okay, great. Now let's move on to the next preview question. There's this one. And start. Collecting the answer. 3, 2, 1. Okay. So most of you guys got it right. The answer is 37. Does anyone want to come up and explain how they solved the problem? Okay, so this question is pretty similar to the last one, except you basically just do it the other way around with subtraction. It says that it's counting back by 7, and the first three numbers were 193 and 86. What is this 10th number? So if there are 10 numbers in total in this arithmetic sequence, and that means that there are going to be 9 intervals. So 9 times 7 is 63, and 100 minus 63 is 37. So it basically works the same as the last one. And now let's move on to the last preview question. And there we go. Okay. So the accuracy rate is actually pretty high, honestly, because this is a geometric sequence instead of an arithmetic one. I'm gonna work. So I was talking about this before we started the actual preview. It says that the Incredible Hulk can double the distance it jumps with each succeeding jump. The first jump is 1 meter, the second is 2, and the third is 4 meters, and so on. And it asks which jump it will first be able to jump more than 1 kilometer. So this is pretty similar to some of the bouncing problems we did in the first class on fraction. So we note that 2, that means that we'll be multiplying each number by 2. So we note that 2 by the 10th power is 1024. This is going to be the first time that it jumps over like 1,000 meters. That means that there are 10 intervals. So 10 plus 1 equals 11. and our answer will be 11. Any questions? Okay. Then let's move on to the content of our class today. Firstly is the general formula of arithmetic sequences. So the definition, as I've said before, is basically for a sequence, if the distance between every term and the previous is the same and it's like a natural number, then it is an arithmetic sequence. Where this difference is common difference, it is commonly noted as D, which is like common difference. And the rule for the arithmetic sequence is that the nth term of an arithmetic sequence with the first term, which is usually noted called as A1, and the common difference D can be found by using this following formula. So basically what it says is that n minus 1, this means n is the nth term, n minus 1 will be the number of intervals. So this also reflects back to some of the problems we did in the preview, and basically I'll explain it with an example question as well. So for the arithmetic sequence an, given that the first a1, which means the first term, is -4 and the fifth term is -12, then there are going to be 1, 2, 3 in between, and this is going to be -12. Then A3 is, so basically we see that we have 4 intervals, and since 5 is going to be an, which is, so n equals 5, let's say n equals 5, then putting it back into the formula, we have 4 intervals, which means we just do that. -12 minus 1 minus -4 is -8. So since we have 4 intervals, we can just do -8 divided by 4 equals -2. So our distance, common difference, is -2. Therefore, the third number of the sequence, we can just do the first term -2 minus 2 equals -8. So our answer is -8. Any questions? And if we put it back into the formula, following it strictly, then that means we are trying to find, let's go up. That means we are trying to find out an, which is A3, equals A1 plus 3 minus 1 times -2 equals -4 plus 2 times -2, which is -4 minus 4 equals -8. So that proves our formula. If there are no questions, then let's move on to our practice one. Oh, let's do we have another exploration question before that, so we'll also review that. 15 integers A1 to A15 are arranged in order on a number line, and the integers are equally spaced and have the property that one is, so A1 is not less than 1, but also not more than 10, and that also applies to 13, A2, 20, 241, A15, and 250. So this seems like quite a complicated question, but I'm going to explain it. So the second inequality, it shows us that A1, so A2 is going to be the same as A1 plus the common difference, right? So it shows that 13, A1 plus D, and 20. So the third inequality will give us from 241 A1 plus 14D, because there are 14 intervals, 15 minus 1 equals 14, is no more than 250. So we need to find the difference between the two inequalities above. So we can solve this by doing this. 241 minus 20 is no less than 13D, is no less than 250 minus 18. So we have 221 no less than 13D, no less than 237. So by simplifying and dividing by 13, we have 17, D, and 19. Therefore, since they are all integers, D can either be 17, 18, or 19. However, we also have 14D is larger than 250, as we shown before. So 14D is larger than 250. Wait, larger than 240, 50. Therefore, the difference can only be 17. Because 1D is equal to 18 or 19, then it is larger than 250. Because in here it says that 14D has to be less or equal than to 250, so that means that this cannot be true. Therefore, D can only be 17. And we also know that 13 is no less than A1, the first number, plus 17, no less than 20. Therefore, we have -4, A1, and 3. Then 240, then by plugging this back into the previous equation, we have 241 is no less than A1 plus 14 times 17 here is no less than 250. So we have 3 is no less than A1, no less than 12, and therefore A1 equals 3. And A14, just to verify, is going to be 3 plus 3 times 17 equals 224. And the sum of the digits is 2 plus 2 plus 4 equals 8. So going back to the problem, we have our answer is going to be 8. Any questions? If not, then let's move on to our practice problem. I'll give you guys some time to do this one first. Okay, 2 minutes is up, I'll end. So it seems like most of you got it right, which is great. Does anyone want to come up and explain how they solved the problem? If not, that's okay, because it is pretty easy one. It says that the sequence is an arithmetic sequence with the second term is, let's say the first term is, A1. The first term is A1. And the second term is -6. and the eighth term is 6. So we're going to have 1, 2, 3, 4, 5, 6, 7, and then the eighth term is 6. Then A9 equals. So the interval we have in total is going to be 8 minus 2 equals 6. So 6D is going to be the same as 6 minus negative 6 equals 12. So our common difference is 2. Then the ninth term is going to be 6 plus 2 equals 8. And that's our answer. Next we have our second concept, which is properties of arithmetic sequences. So if let's say an is an arithmetic sequence, then we have 2an, which is going to be 2 of a specific term. It's going to be the previous term plus the term after. So let's say we have a and a plus d with a minus d. Then a is just going to be the same as a minus b plus a plus d, right? Which is just going to be, you cancel it out. Then 2a is going to be 2a. So these two added together is going to be 2 times the term in the middle. And that is actually also going to apply to a1 plus an. So let's say we have the first term and blah 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 to the nth term. So those two added together is going to be the second term plus the second term, a2, and this together. So the reason we have that is because the second term is just going to be a plus d, and all the way to, let's say, a plus, just say a plus nd. So the next term after that is going to be a plus n plus 1d. So together, these two together is going to be 2a plus d times n plus 1, which is going to be the same as a plus n plus 1 times d. Does anyone have any questions? And this means, let me actually screenshot this. So, and for the last property, we have this. So if k plus l, let's say there are 4 numbers, k, l, and n, and they are all natural numbers, natural integers, then that means that the kth term plus the lth term is going to be the same as the mth term plus the nth term, as long as k plus l is the same as m plus n. So for an example, let's say there is a1, and let's say that the first term of a random sequence is 1, and the third term of the random sequence is 3. So the interval is going to be 3. A3 equals 3. So we have 1 plus 3 equals 4, and 2 plus 2 is also 4. So let's say a2 is 2. So a2 plus a2 is going to be a2 plus a2 is going to be 2 plus 2 equals 4, and these two together is also 4, but at the same time the number of terms that they are in the sequence is 1 and 3. 1 plus 3 is the same as 2 plus 2, so that proves our third property. So you guys don't really have to remember these by heart, because they are easy to prove and you can just do them as you go along with the problem. But anyway, moving on to our first exploration problem, is that for the arithmetic sequence an, a random sequence, given that the first 3 terms, given that the first 3 terms, the sum is 3 and the fifth term is 10, and the values of a1 and d are. So we have that, according to the property from before, we have that a5 is the same as a1 plus 4 times the common difference equals 10. So we have a1 plus 4 times the common difference equals 10. But we also have that the first 3 terms together is 3. So the second term minus d, which is a1, plus the second term plus the second term plus d again. So this, I'm gonna isolate, sorry. So let's separate them like this. This is going to be A1, this is A2, and this is A3. So these plus together is 3. So we have 3A2 minus D plus D equals 3. So by canceling that out, we have that A2 is 1. So A2 is 1 equals A1 plus D. So we have A1 plus D equals 1. And by plugging this back in here, we have that 3D equals 10. 3D equals 10 minus 1 equals 9. So our common difference is going to be 9 divided by 3 equals 3, which is D. That's our common difference. And by plugging it back into the original equation, we have 1 minus 3 equals negative 2. And that is going to be A1, our first term. So therefore, our answer is A. Any questions? If not, then we'll move on to our second question. The second question is based on a number line. That 3 positive integers are equally spaced on a number line. So let's draw that one first. In number line, the middle number is 20, and the largest number is 3 times the smallest number. So since they're equally spaced on the number line, it means that they are part of an arithmetic sequence. They have a common difference. And the largest number, which is 20 plus D, is 3 times the smallest number. So 20 plus D is going to be the same as 3 times 20 minus D. And by expanding it, we have 60 minus 3D is the same as 20 plus D. And now all we have to do is just solve the equation, which is 60 minus D is 40. So 40 is the same as 4D, and we have that our common difference is 10. So therefore, the smallest of those three numbers is going to be 20 minus 10 equals 10. Are there any questions for this one? If not, then let's move on to our practice problems. We have 2. Let's do the first one first. Is there a question? Is there a question?
No, accidentally touched it.
Oh, okay. 8 times up. Feels like most of the people were able to get it correct. The answer is 180. Does anyone want to explain how they solved the problem? There are actually two ways to solve it. The first one is I'm going to use the formula that we learned before, that the two numbers on the side is going to be the same as the sum of the two numbers in the middle. So let's say that there are A3, so there's A3 and A7. So A3 and A7, the sum is going to be the same as A2 plus A4. And the same applies to these two numbers. But for A5, for A5, I'm going to sorry. That means the 2 of A5 is going to be the same as A4 plus A6. So 2A5 is the same as A4 plus A6, the same as A3 plus A7, and which is the same as A2 plus A8. So let's say that A5 is x, so x equals A5. Then that means we have 2x plus 2x plus x equals 450. 5x equals 450, and A5 is going to be 90. So now that we know that A2 plus A8 is going to be the same as 2 of A5, then that will be 2 times 90 equals 180. And there is also a second way to solve it. This is M1. The second way is just using A1. So let's say that A3 plus A4 is going to be A1 plus 2D, and A4 is going to be A1 plus 3D. So we have A1 plus 2D, that's A1 plus 3D, 4D, all the way to A1 plus 60. Wait, okay, let's just but whatever. But now we have 5A1 plus 2 all the way to 6. That's going to be 21 minus 1 equals 20D equals 450. Therefore, A2 plus A8 is going to be the same as 2A1 plus 8D, and that is going to be 2/5 of this, which is 2/5 times 5A1 plus 20D equals 2/5 times 450 equals 180. So both ways we can get that the answer in the end of 180. Are there any questions? If not, then we can move on to our second question. Is there a question?
Like, can I see the step for practice 2 again?
Okay. Is it this one?
Yes.
Let's see. You can take a screenshot.
Okay. Okay, I'm fine.
Okay. Okay, have to get the answers in. So the rate is really, really high, which is great. Does anyone want to explain how to solve the problem? Okay.
I think basically, to be honest, I just kind of guessed it.
So like, but do you know how to solve it?
I just kind of want to ask what the right way to solve it is. Well, I just tried like a few numbers and I thought like, yeah, because.
Oh, okay. But basically, we can just use the method that we used last time. I'm still going to. Wait, let's see. So, the answer is 6. Wait, the answer is C. Oh, another one? Yes? Oh, never mind. Okay. Then we have, so basically the middle number is 15. It's the same as the last one. The middle number is 15. And the largest number is 4 times the smallest number. So by using the variables, let's say the distance, the common distance is d, then the largest number is going to be 15 plus d, and the smallest number is going to be 15 minus d. So it is 4 times. That means this is equal to 4 times 15 minus d equals 60 minus 40. And then we have 60 minus 15 is the same as 4d plus d, which is 5d, and d is going to end up being 9. So therefore, our answer is going to be the middle number minus 9, which is 6. And then we have our answer. Are there any questions? If not, we can have a 5-minute break. And let's see. There we go. Yes, the question. Hello.
I just accidentally clicked on it.
Oh, okay. Okay, time that. Okay, so now we can, as you guys are back, you can turn on the camera and we can move on to our next concept. If there's time, we can go back to the extension. So, next concept is finding the number of terms in an arithmetic sequence. The general term of an arithmetic sequence is just going to be denoted as an, which is the nth number in the sequence. So it's just going to be, as you know before, the first term plus the number of intervals, which is going to be n minus 1 times the common difference. So for solving for n, which is the number of terms, we have n equals, we can just ignore the x, equals an, the nth number minus the first number divided by the common difference plus 1. So it might seem a little bit complicated, so I'm gonna explain it with a quick practice problem. Basically, we have this arithmetic sequence, and let's first find the common difference. It's going to be 16 minus 13 equals 3. So ask how many terms are there. There are the first number a1 is 13, and the last number an is 73. So to find the number of terms, we need to first do the 73 minus 13 is 60, and divided by the common difference, right? That seems pretty simple. Divided by the common difference, that's going to be 20. However, we need to keep in mind that there is still an extra number. So if it's 73 minus 13, then we're basically just ignoring the first term, which is 13. Which is 13. So in order to include 13 in a number sequence, we need to add one term, which is 20 plus 1 equals 21. So therefore, there are 21 terms in this arithmetic sequence. And just to do a quick verification, and there are 21 terms, there are going to be 20 intervals, so that's going to be 21 minus 1 equals 20. Verification. Then we have 20 times the interval, which is 3, equals 60. And so the nth term and the last term in the sequence is going to be 60 plus 13 equals 73, which is our last term. So therefore, the verification, the double checking is correct, and there are 21 terms in this arithmetic sequence. I'm gonna screenshot this formula for you guys to see, just in case, and bring it down. But now let's move on to our practice problem, which is pretty similar. Set it up real quick. There you go. Okay. So mostly everyone were able to get it correct. The answer is, let me first check it out, 23. Is anyone willing to describe their process for doing the problem? Okay.
So you could just first do 70 minus 4, which gets you 66.
Wait.
And then you divide it. You divide 66 by the difference.
3 divided by 3.
Which is 3. And that gets you 22. But then you have to add 1, so you get 23.
Great. Okay, perfect. Thank you. So, pretty simple. We just have to plug it into our formula. And that's it for this concept. Then let's move on to the next one, which is going to be one of the most important parts about arithmetic sequences, which is finding the sum of all of the terms in the sequence. So the expression formed by adding the terms of a sequence is called a series, which is denoted by S. So the sum of the first n terms is going to be denoted by Sn, and the sum of an arithmetic series or sequence that has a limited amount of terms is going to be the sum of the first n terms of an arithmetic series is the average of the first n terms multiplied by the number of terms. So let's say n is going to be the number of terms. So that means that we will also have to find out the number of terms beforehand. Then we can just multiply it by the first term plus the last term divided by 2. So I'm gonna isolate this equation 2 just in case, and let's move on to our first exploration problem. A triangle, let me move it down real quick. A triangular array of 210 coins has 1 coin in the first row, 2 coins in the second row, all the way up to n coins in the nth row. What is the sum of digits? What is the sum of the digits of n? So we have 1, 2, 3, and all the way to, we don't know how many, right? So it says that there are 210 coins in total, which means that Sn is going to be 210. Then we have that we don't know what n is, but then we know that the first term is 1, so that's going to be n times 1 plus an divided by 2 is 210. So therefore we have n, so by expanding this equation, we have n times n plus 1 divided by 2 equal 210. So that means that n times n plus 1 is 420. Then now we have, so basically we can just plug it into some integer. So if we know that there are just going to be real integer numbers, and by plugging it in, we know that we can just 凑数. So we can just do 20 times, we know that 20 times 21 is 420. So the answer is just going to be n equal 20. So that's pretty simple. And it asks for the sum of the digits of n, so 2 plus 0 equals 2. And I guess we can try to prove this formula. I'm going to briefly explain it. Let's move down first. So for this formula, it says that, let's say, a plus d all the way to a plus nd. So n times a plus n d divided by 2. So n is basically the number of terms that we have in total. So that's going to be a plus nd minus a again, and divided by the interval plus 1. But then we know that from the equation before, the first number and the last number the first number and the last number together is the same as the numbers in the middle. So that's going to be like, let me expand it real quick. We have A1, we have A1, A plus D, then all the way to A plus N minus 1D, and A plus ND, right? So from the equation that we learned before, these two together is going to be the same as these two together. And by applying it to all of the like the terms in the middle, then we have that this entire equation is just going to be A plus the first term plus the last term times the number of the terms times like the number of the terms that they have in total divided by 2 because there are two numbers on both sides. So that means that if we divide that by 2, then we have that the number is then we have to like the sum of the series. But if we have an odd number of numbers in a term, that means that the number right in the middle is going to be, let's say that this has 9 terms in total, then the number right in the middle is going to be A5. But then, as we know before, 2A5 is going to be the same as all of the numbers on the side added up together. So therefore, we can just apply the same thing and add the first number and the last number, which is going to be the same as all the sums of the terms in the middle divided by 2. So that's why this equation works. But anyway, so after proving that, we can move on to our next problem, the sum of 5 consecutive numbers. Let me isolate it real quick. That the sum of 5 consecutive even numbers that means that it's basically an arithmetic sequence, except that the common difference is 2. It's 4 less than the sum of the first 8 consecutive odd counting numbers. What is the smallest of the even integers? So since it says that there are the sum of the first 8 consecutive odd counting numbers, that means there's 1 plus 3 plus all the way to 8 minus 1 equals 7, and 7 times 2 plus 1 equals 15. So this is going to be all the way to 15. So that the sum is going to be 1 plus 15 divided by 2 times the number of terms, which is 8, and that'll be 8 times 8 equals 64. So it says that the sum of 5 consecutive even integers is 4 less, so 64 minus 4 equals 60. But then we also have, let's say that the first number in the sequence is n. Then we have n plus 2 plus n plus 4 plus n plus 6 and n plus 8 equals 60. By expanding the equation, we have 5n plus 24 equals 60. Wait, 5n plus 20, sorry. So 2 plus 4 plus 6 is plus 8 is 20 equals 60. So therefore 5n equals 40 and n equals 8. And the first term of our even integer sequence is going to be 8. Are there any questions? If not, then we can move on to our practice problem. Quite similar. Let's go. Okay, so then we have that the correct answer accuracy rate is pretty high. Does anyone want to explain how they did the problem? Okay.
So first, Zoe read her first book for 1 day, second book 2 days, and so on and so on. So the question tells us that when Zoe with each book takes her 1 more day to read than the previous book. So the question tells us she finishes the first book on Monday, the second book on Wednesday, so we can know that she finishes her third book on Saturday.
Mm-hmm.
Then the fourth book she will finish on Monday. So we will see that there is a sequence. So the sequence is 3 days. So 15 divided by 7 is divided by 3 is 5. So it's Monday.
Okay, perfect. Thank you. Wait, let's see if I can. Wait, sorry. I can't really do it on my iPad, but there we go. Okay, thank you. So this is actually pretty smart and the fastest way to do this problem. But since we're doing sequences, I'm going to also show you guys the way to do it using sequences. So we're using this formula that we had before, 1 plus 2 plus 3 all the way to 15. It's going to be 15 plus 1 divided by 2 times 15 because that is the number of terms we have in the sequence. So that's going to be 8 times 15 equals 120. But then it says that she finished the first book on a Monday, and we can just divide 120 by 7, which is 7 days in the week, and we have 119 or 1. We basically have remainder 1. So both of them must happen the same day of the week. So since she finished the first book on a Monday, the answer is just going to be Monday. Okay. Is there a question?
Like, I don't really get why it's like a repeating pattern with Monday, Wednesday, and Saturday. Because, like, I think, like, for the fourth day, so Saturday plus 4 days is Wednesday, isn't it? Or
Saturday.
so
We have,
I'm not really
okay,
sure.
so I guess we have Monday, Wednesday, and Saturday. Then there is Thursday, which is on so Wednesday for 1, 2, 3, 4, and 5. So again we have like that means that we're back to, I believe, Monday. So I think 3 is actually not the number that we should be dividing 15 by then, but basically we get the idea that so basically we get the idea that 5 is the number we should be dividing it by, I guess. So then there is the 15 minus 15 divided by 5 equals 3. Yeah, so that's correct for this method. Then that will be divided by 5. But then since we have no remainder, then the answer is going to be Monday. And for this one, since we have one remainder, then wait, what? Yes? Did you say something?
Oh, sorry. I think I didn't turn my microphone off.
Oh, okay. Okay. So since there are two methods, for this method, since the remainder is 1, then we can just go back to the first number of the sequence, which is Monday. But for this one, it says that since there are no remainder, then the remainder is 0. Then we take the last number of the sequence, which is also Monday. So either way, the answer is going to be Monday. Anyway, let's move on to our last concept, which is Fibonacci sequences. This one is going to be a bit different from the one before. It's just not an arithmetic sequence. So just to test what you guys know about Fibonacci, I'm going to do a warm-up question. This one is pretty long actually. Actually, since it's pretty so long, I'll just explain it directly. Let's take it. So in the kingdom of immortality, when no one dies, a pair of baby bunnies is born, which can become adult rabbits in the second month and give birth to another pair of bunnies in the third month. After that, they will give birth to a pair of bunnies each month. The newly born bunnies will become adult rabbits a month later and then give birth to a new pair of bunnies each month. And therefore, by the end of 1 year, which is 12 months, how many pairs of rabbits and bunnies will be in total? So as we can see from the diagram below, they have one first, one, wait, yeah, one pair, and then one pair again, then there are two pairs, and then there are three. So as we can see, 1 plus 1 equals 2, 1 plus 1 equals 2, and 1 plus 2 equals 3. So that is how we get the next number, and this is the Fibonacci sequence. So the idea of a Fibonacci sequence is that the basic one is going to start with 2, 1, and the next number is going to be the sum of the two previous numbers. That's going to be 2. And the next number will be the sum of the two previous numbers and all the way until, well, it ends somewhere. And there are also other types. Maybe we have like 1, 1, 2, and the next number is supposed to be the sum of 3 of the previous numbers, which is 4, and so on. But in this question, we can see that we just have to use the first one, which is the basic one. So we can do something like using the chart as assistance. So we have 1, 1, 2, 3, and that's going to be 5. 3 plus 5 equals 8. 5 plus 8 equals 13, and all the way until that's going to be 55 and 89, and the last number is going to be 144. So therefore, by the 12th month, there are going to be 144 pairs of rabbits and bunnies, because we have to add them together. And for this one, we can also do, so 2 plus 2 equals 4, and 2 plus 4 equals 6. So that means that this Fibonacci sequence, we only have to add up the two previous numbers. Then by filling in the blanks, we have these, which is pretty simple. Are there any questions? If not, then let's move on to the different types. So this one, we can say 1 plus 1 plus 1 equals 3, and 1 plus 1 plus 3 equals 5. So this means that for this one, we're going to be adding up the three previous numbers. So for this term, it's going to be 3 plus 5 plus 9 equals 8 plus 9, and that's going to be 17. And you can double check with the numbers after. So the third one is that 1, 2, 2, 4. So it seems that starting from the third number, the following number is the product of the previous two numbers. So 4 is 2 times 2, and 8 is 2 times 4. So the next number is going to be 8 times 4 equals 32. So the pattern is going to be quite similar, but they're going to be different for each sequence. And for these type of problems, you guys will have to try and figure that out yourself. And for the last problem is 3, 1, 3, 3, 9. And this one seems a bit weird, but usually the first two numbers don't really matter. And it says that starting from the third number, the following number is the product of the previous two numbers again. So 3 times 1 equals 3, 1 times 3 equals 3, 3 times 3 equals 9, and for this one, it's going to be 3 times 9, 3 times 9 equals 27. Are there any questions about the warm-up? If not, then let's move on to our exploration problem. It said that let the first, let me isolate this one. Let the first number of the Fibonacci sequence be 1, then 3, and it says that Ln plus 2 equals the two previous numbers plus together. How many terms in the sequence L1 to L2 to 2023 are even? So we have 1, 3, 4. So let's first fill out 4. We have 1, 3, 4, then 7, and 11, and 18. So all the way we see that every three numbers, the last number is going to be even, every three numbers. So what we have to do is basically 2023 divided by 3 is going to be 1800 plus 210 plus 13 divided by 3. And then we can see that this is divisible by 3. So 13 divided by 3, we have a remainder 1. Wait, so we have 600 plus 70 plus 4 equals 674. So we can just ignore the remainder and our answer is going to be 674. Are there any questions? If not, then let's move on to the next one. So this one seems a bit more complicated. David and Andy need to climb a staircase with 10 steps. Let's first do this one. So each step of the bar, David can only ascend 1 or 2 levels of steps. Then there are how many ways for him to reach the 10th level? So to do this problem, we have, this is the first step, then this is the second. So there is one way to get to the first step. So let's write that down as 1. And for the second step, there are 2 ways. There you can do like, she can step up 1 at a time, or she can just do this. So the second number of the sequence is going to be 2. Then we can notice the third number. The third number, how many ways are there to get to the third step? So he can either do 1, 2, 3, or he can do 1, 2, or 2, 1. So there are going to be 3 ways for him to reach the third level of steps. And by noticing the pattern, we can see that it is a Fibonacci sequence. The next number is going to be the sum of the 2 previous numbers. Therefore, there are going to be 5 ways for him to get onto the 4th step. And for the 10th step, we can just do 1, 2, 3, 4. Then 5, 6, 7, 8, 9, 10. 3 plus 5 equals 8. And then 13, 21, 34, 55. And lastly, 89. So there are 89 different ways for him to reach the 10th step level of steps. Any questions? If not, then let's move on to Andy. So it says that he can climb 1, 2, or 3 steps at a time. So a bit more agile, I guess. Then how many ways are there for him to climb up to the 10th step? So again, there is 1 way for him to climb up to the first, 2 ways for him to climb up to the second, but for the third one, there are going to be 3 ways again, 1, 2, 3, 2, 1, and 1, 2. But then we know that there is a 4th way because he can step 3 steps at a time. So therefore, it is going to be 4. So, and we notice that for the next one, since he can climb, there are 3 ways for him to climb up at a time. Then we have 1, 2, 3, 1, 2, 4. Them added together, 1 plus 2 plus 4 equals 7. So the next number is just going to be the sum of the 3 previous numbers. So for the 5th step, it will be 2 plus 4 plus 7 equals 13. And moving on, that will be 4 plus 7 plus 13, 24. And 44, 81, 149. And lastly, 230 plus 44 is going to be 274. Then there are going to be 274 different ways for him to climb up to the 10th step. Any questions? If not, then let's do a practice one. Move it down first. You guys can start working on it. thumbs up. Most of you guys got it correct. The answers are 8 and 55. Does anyone want to explain their method? Okay. Yes. Wait, hello. Is it that the audio interrupted? I can't really hear you. It's okay. Yes.
So the first question asks us how many different ways this person can walk down the 5th step.
Mm-hmm.
So I drew 5 steps, and then from the first step, there's only one way.
Mm-hmm.
The second step, we have 2 ways. The third step, we have 3 ways. So the fourth step is 6, and then the fifth step is 2 plus 3 plus 6, which is 8.
Huh?
I think. Wait.
I
didn't think I quite did it right. Yeah, maybe I did wrong.
Oh, it's okay, because like the next problem, the next step is there are only 1 or 2 steps at a time. So the next step is just going to be 2 plus 3. The 2 previous number is 5, and then the 5th step will be 3 plus 5 equals 8. Together, that will be 8.
Oh, okay.
But that's okay. Nice try.
Okay.
And oh, okay, that's okay. So microphone is broken. It's fine. It's fine. But anyway, let's move on to our second question. It's going to be it's basically the same except it asks for the 9th step. So 1, 2, 3, 4, 5, then 13, 21, 40. Wait, never mind. 34 and 55. 1, 2, 3, 4, 5, 6, 7, 8, 9. So our answer is 55. No questions. And now let's move on to our last practice problem for today. Don't you guys pull for this one? There you go. Okay, getting the answers, and most of you guys chose E, which is the correct answer. So for this question, it says that you can take the stairs 1, 2, or 3 at a time. So using the problem that we used in the exploration, let's draw a flight of stairs first. This first step is going to be, there's only one way. The second, there's 2. And for the third one, there is 1, 2, 3, or 2, 1, and 1, 2. However, there's a fourth way because you can take the stairs 3 times, like 3 steps at a time. So there are 4 ways. Therefore, for this sequence, we have 1, 2, 4, and the next is going to be 1 plus 2 plus 4, which is like the 3 numbers added together, and that's going to be 7. So lastly, there will be 2 plus 3 plus 7, 2 plus 3 plus 7, which is 13, and we need to find out which the sixth step, I believe, right? You climb the flight of 6 stairs. So the next one is going to be 2 plus 4 plus 7 equals 13. And the sixth step is going to be 13 plus 7 plus 4, which is 24. So therefore, the answer is 24. And that's all for today. Are there any questions? If not, that's basically all for today. Congratulations on completing that class, and I'll upload the assignment after class, on a classroom, okay? Thank you guys, and bye.